My name is Gina Abascal. I'm a junior at UF Online and I'm majoring in computer science. I'm currently living in Gainesville, Florida, and I plan on working as a software engineer after graduation. My hobbies include baking and hiking.
And my name is Jonathan Phillips. I just started my fourth year in undergrad, majoring in computer science at University of Florida. I'm interested in programming and working with others to create games for anyone to enjoy. Here, I'm from Jacksonville, Florida. My hobbies include working out, exercising, and gaming.
I'm Tyler Westcott. I'm a post-bac student at UF Online, majoring in computer science, and I plan on using the high-level courses to qualify for more competitive graduate programs. I live in San Diego, and my hobbies include travel and hiking. Rohan, I think you're on mute.
Oh, sorry about that. Hi, my name is Rohan Singh. I'm also a post-bac at UF Online with a major in computer science. I'm currently employed in finance, but interested in making a switch to computer science after graduation. I'm based in Jacksonville, Florida, and my hometown is Washington, D.C. My hobbies include tennis and running. Okay, well, thanks everyone. So with that out of the way, our project idea, the problem that we're trying to solve is a lot of us as students trying to break into the computer science field. Computer science and software engineering is a great career choice with tremendous career prospects, but opportunities are not distributed evenly across the US. There are several hotspots, such as in California, Washington State, Texas, and a lot of other cities. But if you do not live near a CS hotspot, or you don't come from a CS background, you may not be as exposed to the industry or the opportunities that are available to you. You may also have fewer contacts and networks in the industry, making it harder to know where to look and how to break into the industry to get your foot in the door. Furthermore, CS is a complex and large field with many different roles available, including back-end engineer, front-end engineer, full-stack developer, product manager, QA tester, etc. It can be tough to know which role to prepare for and which type of role will best suit your personality and technical strengths. While some students may have early contacts into the industry to give them a glimpse of the different career paths available, or private career coaches, the students may not. It can be helpful to know which type of role will best suit you so that you can prepare for this type of role and set yourself up for success. With that, the proposed solution is, a student or young professional, is naturally wondering which of the CS role is best suited for them. Our solution is a website, so they can go on this website and take a 20 multiple choice question. This survey, multiple choice question survey, this survey will assess the test takers' personality and technical strengths to get a sense of who they are. And then based on the test takers' natural attributes and technical strengths, they'll propose a CS career path that is best suited to them. So to propose a back-end engineer or a front engineer, propose that they be a QA tester or a product manager. Once they finish the survey, they'll get a tag on their profile that has that career path for them. Hopefully that'll give them a better understanding of which type of role is best suited for them. They'll also then be able to access a database where they can see other students who have taken the test and also connect with employers who are looking to hire people into those types of roles, so they can connect directly with employers and look to get hired. And we hope this is a good solution to get people A, focus on their career path early on, and B, connected to employers early on so they can begin networking and begin their careers. I think you're on mute, Gina.
For coding the backend portion of our website, we'll be using the simple and adaptable programming language Python. We'll be using Flask as a web framework for Python to help us create and manage our website. For our user interface, we'll be coding in HTML, CSS, and Java. Using HTML, we'll create the structure of our website. CSS will be used to tailor and style formatting, and JavaScript will make our web page interactive. We will not be using any pre-made APIs for our project. Instead, we will create our own APIs where needed. AWS Elastic Beanstalk will be used to host our server, and AWS Elastic Load Balancing will be used in conjunction to distribute incoming website traffic across servers. This will help to improve the performance and speed of our software. In order to manage our software and code collaboratively, we will be employing the use of GitHub. Jira will assist us in the project management side of software engineering. We'll use it to keep track of tasks and the progress of the project. We will be using a client-server pattern as our architectural pattern. This pattern works by having clients that send requests to servers. The servers then process those requests and retrieve any necessary data from a centralized data storage and then proceed to send a response back to the client. So here we have created a visual for how this client-server pattern works. You can see that each client is sending requests that are distributed via the load balancer and receiving relevant information back.
All right, and next is to briefly go over some of our highest prioritized user stories for the project. We first have the data storage for our logging functionality, basically stating that as a student looking for connections, it's going to be important to have the functionality of logging in with the username and password, which the site can use to save respective data for later use. And following that, we have our career type match, stating that it's important for the site to effectively provide career paths which are accurate to survey-related responses for each user. This gives users the ability to search for opportunities to find future jobs, which they will thrive in most. And then next up, we have the progression timeline display. This user story basically explains the necessity of the site employing a progress bar for a survey, which it gives out to the users. In turn, this functionality assists the users with keeping up, contrary to their completion with the survey, since some may have a tighter schedule and will be unable to finish the survey in one go. And lastly, for our highlighted user stories, we have student connecting with startup founders. As a computer science student, it's important and necessary to have the option of easily networking with startup founders, which have available specific positions for users to partake in based on their best skills given by the survey. And next up, we have the product backlog overview. Our first PBI is the survey development itself, consisting of the creation and employment of a survey containing approximately 20 questions for any user to fill out. Our collaboration in playing poker estimated a value of 5 points and complexity. The decision-making process and overall creation of a survey has been agreed upon by all of us, where it would not be too hard to develop for the site. And our next PBI is the design and creating backend data structures. This PBI involves the use of data structures to store user accounts according to a username and password delegated by the users themselves. Alongside this, user information regarding survey responses, computer-generated assessments, and respective career path tags are also stored with each individual user via the data structures. And in the end, we collaborated upon a value of 13 points for planning poker, considering the possible complexity of data structures used to achieve said functionality. And next up, we have networking features implementation. So this PBI relates to the functionality of a working search bar, which users can use at any time post-survey completion to have a chance to work or talk with others based on career path tags they look up. We held a group consensus of a planning poker value at 8 points, considering that this functionality builds off from our backend data structures and is still holding a higher complexity than implementing the survey. And our next PBI is user interface design and implementation, incorporating a user interface that is hopefully pleasing to the users and easy to follow along. That being said, our group has come to the consensus of a planning poker value of 55, which is our highest complexity by far. To elaborate further on this group decision, all of us have we do not have any prior experience and generally low skill with front-end coding for designing objects such as user interfaces for a working website. Although it may be a bulk of work for our projects, we agreed that all of us would collaboratively work together to put the interface for the site. And our last PBI is the deployment and integration setup. So this sets up hosting and deployment processes, enables integration for regular development and updates, as well as ensuring that the program is accessible to a broader audience through a hosted program. Given this, we collaborated to a planning poker estimate of 13, assessed that this task has an estimated effort of similarity with designing and creating our backend data structures.
Right. For our sprint planning process, we've created 6 epics to categorize every task in our sprints. 5 of these are directly related to the product backlog items designed during Module 5, which cover core functionalities. The 6th epic focuses on project management tasks, which will ensure smooth progression and organization as we complete the project. Sprint 1 starts today, March 20th, and concludes on March 29th. We've chosen 5 tasks under 3 epics, which is shown on our Kanban board below. Our goals for this sprint include completing the survey development epic and making significant progress in the user interface design epic. We're also focused on designing user tests and preparing our Sprint 1 assignment for Module 11, which is due on April 2nd. Looking ahead, we've outlined tentative tasks for Sprints 2 and 3. Sprint 2 will target the epic data structures, as well as the epic's networking features and user interface design. We plan to complete these in this sprint. Where tasks are not able to be completed, we will simply move them to the final sprint, Sprint 3. Sprint 3 will focus on deployment and integration testing, which will ensure that our project is ready for launch. This will include user acceptance testing and bug fixes. This sprint concludes with our final project submissions. As we progress, we may refine tasks for more detailed work with updates to our Kanban board. Our aim is to keep the project on track and transparent for all team members. And this concludes our presentation.